Hello everyone. Our project title is Next Word Prediction using customized dataset. These are all our content: introduction, objectives and constraints, dataset, model, result and conclusion. First, we are going to talk about the introduction. Next word prediction. Next word prediction is a natural language processing, which is a NLP task in which a model is trying to predict the next word in a sequence of words based on context of the previous words. The task can be useful in various applications such as language translation, speech recognition and text generation. To train a next word prediction model, a custom made data set is typically used. The data set should consist of large number of sequence of words, with each sequence representing a context in which the next word should be predicted. The model is then trained to analyze the context of each sequence and predict the most likely next word based on this context. There are several approaches that can be used to train a next word prediction model, introducing machine learning algorithms such as neural network and decision trees. The choice of approach will depend on the specific requirement of application and the characteristic of the dataset. Next word prediction using customized dataset can be a powerful tool for improving the accuracy and efficiency of natural language processing tasks. Then we are going to talk about objectives and constraints. First, we have objectives. In objectives, our main point is accurate prediction and efficient prediction and generalization. The primary goal of next word prediction is to accurately predict the next word in a sequence based on a context of the previous word. The model should be able to identify the most likely next word with a high degree of accuracy. Next word prediction should be performed efficiently with a low latency and minimal computational resource required. This is important for real time applications such as speech recognition or language translation. Generalization. The model should be able to recognize the new examples and contexts that are not present in the training dataset. This is important for the model to be able to handle wide range of inputs. And next we have constraints: size of dataset and quality of data set, computational resources. First, the size of customized dataset may be limited, which can affect the ability of the model to accurately predict the next word. Large dataset may be more representative of the language and improve the model's performance. Then we have quality of the dataset. The quality of the custom dataset is important for the model's performance. The dataset should be a representative of the language and contents in which the model will be used, and should not consider error or inconsistency. Then we have computational resources. The model may be constrained by the computational resources available for training and prediction. This may require trade-offs to be made between model accuracy and efficiency. Time constraint. There are many time constraints on the development and training of a model. which could affect the complexity of the model and the amount of data that can be used for training.
Dataset. The dataset that we use is song lyrics taken from the internet, then made in TXT format. The following is an example of the song lyrics we use. Like this, and this song we train with the model, and after that, beside that, we also try to run other song lyrics as a dataset to determine whether the program can execute them or not.
Okay, the next section is about the model that we use in this project. In this project, to perform natural language processing, we use LSTM, which is commonly we call long short-term memory. LSTM is a version of RNN or recurrent neural network, which is a sequential network that allows information to be persistent. It solves the problem of vanishing gradient in RNN. Basically, RNN is used for persistent memory as a human remember what is going to happen further when watching a video or while reading a book. They know what will happen further. Similarly, RNN also work in the same way, which is remember the previous information to use it for processing the current input, and then to predict the next output or the next word. So basically, RNN is the model that can be used in natural language processing, but it still has problem about vanishing gradient. They cannot remember long-term dependencies. But this problem can be solved in LSTM. So that's why we use this model. So first, we built a sequential model in here. Then we add LSTM layer here and give 75 units, 75 in here. This value is the number of words in our dataset that we used. And also we fill input shape here, where the input shape is the pre-processing dataset we used. And finally, we pass it through an output layer with the specific vocab size and also a softmax activation in here. The softmax activation is to make sure that we receive a bunch of probabilities for the output equal to vocab size. And for the compile and fit function, we use the loss function, categorical cross entropy in here, and for optimizer we use Adam. And for fit model, we use 100 epochs here. And yeah,
Let's move in the result part. In the result part, we already tried use the rhyme.txt file as a dataset. This is the sentence of our testing data inside the rhyme.txt. And the advantage of our dataset is customized dataset. We can add another txt file inside the rhyme.txt, and then easy to replace the sentence inside the rhyme.txt itself. And right now, the current condition of the model accuracy is about 0.99 here in epochs 100, and the loss is about 0.24. And you can see this is the testing prediction in our model. It will create the dictionary with 2 or more keys. In the first will be a tuple of different word sequence, and next key will have the next word. The value of this dictionary will be probability of occurrence of second key given the first key along with Laplace smoothing. And it also generates the sequence of length 2, 3, and 4 from the encoder data maintaining the order of indicate. And it will then split the sequence as X and Y such that only the rightmost index is in Y raised into X. You can see here, this is the testing data in our model. This is the first sentence that I already testing in the validation data sets. Sing a song of, this is, you can see, this is the validation. Sing a song of 6 beats. So the next prediction of this sentence is sing a song of 6 beats a pocket. You can see, sing a song 6 beats a pocket. And then the second sentence is 4 and 20. 4 and 20, the next word is blackbird big. 4 and 20, blackbird big. And then third one is wasn't red a dainty. Wasn't that a dainty dish? And then you can see this is the prediction. Was that a dainty dish 2 days before? And then the fourth, eating bread and honey. Eating bread and honey, the meat was. You must be here. Eating bread and honey, the meat was. So our testing prediction is already true, that the testing is almost correct with our validation data. And couple of things in the other next prediction is we use another type of data set. This is the Twinkle Twinkle Little Star lyrics. You can see. Oh, I wonder, in the second sentence. Oh, I wonder what you are. And then the next prediction is how I wonder what you are up above. That's correct. And then second trial is then you show your little light. Then you show your little light. Almost correct. Then thanks you for your tiny spark. Thanks you for your tiny spark here. Yes, correct. And then the last is like the travel. Here, like the travel in the dark. And then the prediction is like the travel in the dark. And the testing data in our models is almost can validate in our dataset and almost correct with the accuracy about 0.99.
Conclusion. It can be concluded that the LSTM model can predict the next word well. This is indicated by the accuracy reaching 99% and the loss function is only 0.24%. Of course, the comparison between accuracy and loss function shows that this model works well. And even when the dataset is replaced with another song lyrics, it does not reduce the accuracy. That's all our presentation about next word prediction. Hopefully it can be of good use. Thank you. Conclusion. It can be concluded that the LSTM model can predict the next word well. This is indicated by the accuracy reaching 99% and the loss function is only 0.24%. Of course, the comparison between accuracy and loss function shows that this model works well. And even when the dataset is replaced with another song lyrics, it does not reduce the accuracy. That's all our presentation about next word prediction. Hopefully it can be of good use. Thank you.